Hello and welcome to the next round of eVTOL Writers Group interview. Today we have Javier Espuch from Embention, and our moderator today is Kelsey Reichman. Kelsey is the associate editor at Avionics International and is covering emerging and embedded technologies in the commercial and defense aviation space. She previously completed an editorial fellowship with Defense News, covering a range of topics across the defense industry. Kelsey is a graduate of California State University, Dominguez Hills, where she earned a bachelor's in journalism and a minor in photography. While she was in college, she was the editor-in-chief of the student-run publication, The Bulletin. Before I turn it over to you real quick, Kelsey, I just want to remind our audience to submit their questions in the questions box, and you will be taking those questions and moderating the session after Javier's presentation. So with that, Kelsey, I will turn it over to you.
Great, thank you. Well, I'm excited about today's conversation, and I hope that we can, get some good conversation going in this area. So I'm going to introduce Javier Espuch, who is the business development manager at Embention. He's an aeronautical engineer specializing in the unmanned systems industry. He's been working with drones since 2010, and he's responsible for business development at Embention, driving customer and partner relationships to expand market penetration for their autopilot system. So with that, I will hand it over to you.
Thank you, Kelsey. Well, as Kelsey mentioned, I'm the business development manager at Embention, and in our company, we are 15 years working in the UAV and autonomous vehicle industry. And well, now we have a series of developments focused on the eVTOL market that is arising. So I wanted to participate in this symposium to explain a little bit on the kind of equipment needed for doing the eVTOL control. We passed it. Yeah, when we think on eVTOL, well, we are referring to all-electric vertical takeoff and landing systems. But we must consider that there are many kind of vehicle layouts possible, and the choosing one or the other will be based on the autonomy, on the landing area available, the kind of operations that we need to perform, the endurance. Okay, so there are many factors involved in the decision of which kind of eVTOL to use. And obviously, controlling one multi-rotor is not the same as controlling an helicopter or other kind of eVTOL solution with tilting rotors or tilting wings. Besides the aircraft layout, when we discuss on the control, we also need to pay attention to the kind of missions that this eVTOL is going to perform. Okay. Here we have a picture of one of our customers doing this kind of vehicles, that is Skydrive in Japan. Skydrive. And well, they are doing this multi-rotor kind, where they have one person on board with a piloting capacity and also full autonomous capacity. But in terms of the autopilot system and the electronics involved in the control, we need to pay attention to the kind of mission that we are doing to perform. So it is not the same if we need to follow a waypoint route, or if we want to have like a manual control during the whole flight. or if we are doing some kind of a delivery application where the weight when we take off is totally different than the weight when we take off without the cargo. So all these parameters must be considered when selecting the control strategy for the drones. Yeah, going to the technical aspects on the eVTOL vehicles. Well, there are many kind of components involved in the whole flight. Okay, but well, I try to state here the ones that are more involved with the aircraft control itself. Okay, so one of the main components will be the autopilot system, that somehow we can say that it is the brain of the eVTOL, and that will be in charge of managing the guidance, navigation, and control of the vehicle. Then we have some equipment involved with the user experience on board, like the joystick or the user display, that these ones will be the interfaces that the pilot or the passengers will have to interface with the rest of the system. Then we have all the propulsion systems that involves the motor, propellers, motor controllers, and all the electronics needed, so the signals from the autopilot are converted into the real movements of the surfaces. And then we can have a mission computer and sensors and other devices for adding additional capabilities to the eVTOL, like, for example, sense and avoid functionalities, or for GPS denied navigation, or for other applications requiring from onboard video processing or LiDAR data processing, or other kind of applications. Yeah, going to the control inside the eVTOL, we usually find two main areas of the control. One is the automatic flight, in which the eVTOL will perform the flight in fully autonomous mode. And we can find the fly-by-wire functions, in which the pilot or the operator has a joystick or other device to take control of the flight. Usually, the automatic flight is based on the GNS positioning. Okay, so in this kind of systems, we define a route that is predefined in some kind of computer that can be on board, or the signal can come from a signal on a control center or other station in the ground. And this kind of guidance usually involves the use of skyways that nowadays are not available, but it looks like it will be a requirement for the future. So the authorities will authorize some kind of motorways in the sky, where you can control the traffic and authorize the eVTOLs to fly in these areas. And with anyway, in the projects that we are working right now, all of them have both the automatic flights and also the fly-by-wire options. And in this fly-by-wire, we can also find different strategies. So depending on the ability of the pilot, we can give more part of the control to the autopilot, or we can allow full manual control from the pilot on board. Okay, so it is something that also is configurable, and depending on the pilot experience and the kind of project that we handle, we will need to decide which kind of control modes we want to enable. Yeah. When it comes, well, all these, both manual and fly-by-wire control, are usually managed by the autopilot system on the eVTOL. Okay. Well, here I included a picture of the triple redundant Veronte Autopilot that we produce. That is the unit that we are installing in this kind of platforms. Okay. So the main functionalities of this autopilot unit is to do the guidance, navigation, and control of the eVTOL platform. Okay. With guidance, we refer to everything related to what the eVTOL should do on a specific step of the flight or the route. Like, for example, we will define for different control phases. Okay, and each one of the phases we will have a different guidance, like takeoff, hovering, waypoint route, or maybe we can have a phase that is like a hold to flight on a straight direction. Okay, so in the guidance part is where we divide the mission into the different steps that we want to enable, and we configure all the parameters to activate it. In the navigation part is where we read the information coming from all sensors in the system, like the GPS, the IMUs, accelerometers, pressure sensors. Okay. So all these informations come to a Kalman filter into the autopilot, and this Kalman filter processes this data and estimates the position and the attitude of the vehicle during the whole mission. Okay. And the final function on the autopilot system is the control. So now that we know what we want to do, that is defined on the guidance, and we know the position and the attitude from the eVTOL coming from the navigation, we must specify how to control the flight, so the real position and the real attitude of the eVTOL comes to the desired one coming from the guidance. So on the control is where we define all the control laws, the PIDs, the energy control, and well, we have several kind of algorithms that can be used for that. So the result from the control goes to the real movement of the control surfaces on the vehicle, or the real control signal going to the motor controllers, so we can control the whole vehicle. As I mentioned, we come from a deep experience in the UAV market, okay? And an important point when comparing an autopilot solution from a UAV or a drone with the autopilot for an eVTOL is that when you control a UAV, you can do really harsh maneuver, and you can have a really big accelerations, as you don't have anyone on board, and the flight don't need to be smooth or comfortable for the people inside the vehicle. But when it comes to eVTOL control, you need to take all these things into the consideration, because you have a real person on board, and this person probably is not experienced pilot, so he needs to have something smooth and comfortable. Yeah. Another important component for the control of this kind of vehicles is the motor controllers. This kind of motor controllers are the interface between the autopilot solution and the motors. So these units receive the control signals coming from the autopilot that is usually specified as an RPM value, and then it converts this control signal into the power signals going to the motors to make sure that the real RPMs on the motor are the ones defined by the autopilot system. This kind of motor controllers are also a critical device in the vehicle, because a failure on the motor controllers might result on a critical failure of the whole eVTOL platform. So this is why we have decided to develop a series of motor controllers in compliance with the DO-178 and the DO-254 standards, so we can prove that the compatibility with the aircraft standards, and we can have plenty of reliability data for these components. We during these years we have found many companies that they are paying a lot of attention to the reliability on the autopilot systems, but they are not caring so much on the robustness and reliability of the motor controller. But these devices are almost as critical as the autopilot itself, because you have a hardware on board and you have a software that is running critical functions. So the reliability there is really important. Besides these reliability standards that prove the reliability of the system, all this kind of motor controllers also includes embedded self-test and sensors that can provide information and feedback to the autopilot solution, so automatic fail-safes can be activated in case that failure in the motor controller is detected. And one last point to mention on these devices is that, well, nowadays one of the limiting components preventing the use of eVTOL systems more widely is the limitations of the batteries that are not giving the long endurance that we will require for this kind of vehicles. So at Embention, we think that in order to improve this autonomy, one of the major changes that will happen in the eVTOL is that they will move to high voltage batteries, because the more voltage you have, the less power loss you have. So within this motor controller development, we have estimated that the market will go for the from 100 volts up to 500 volts systems in these vehicles. Yeah. Well, I have mentioned already the importance of the certification and reliability for this kind of systems. So when designing the control system and the control strategy for these vehicles, one important factor to be taken into account is the redundancy. If we want to have eVTOL aircrafts flying over populated areas and flying with people on board that are not experienced pilot, we need to ensure that these systems will be fault tolerant. So in order to do that, we need to have a good redundancy management. So in case that any subsystem in the eVTOL fails, the aircraft should be operational and should have the autonomy enough to go to a safety landing area. Together with this redundancy management, we should also ensure that all the hardware and the software controlling the critical functions are developed according to the standards used in the aviation. So this is why all our systems are developed according to the DO 178C and the DO 254 and the DO 160. That these standards make us build a series of documents and tests that can be used for going through a certification program and to prove to the authorities that the system will be safe even in the event of a failure in one of the aircraft components. Yeah, regarding the automation of the eVTOL system, I think that we all may agree that the future of the eVTOL is that all these aircraft are fully autonomous, and there is no need of human intervention at any time during the flight. So for this, we need to integrate detect and avoid technology with the autopilot solution. So with the current state of the art, the autopilot systems already includes avoidance maneuver. Okay, so it can deviate the path from the predefined route in case that an obstacle is detected. But we still need to connect to the autopilot system reliable sources of obstacles. So for this, we find two different kind of sensors. So we have some sensors that we call the collaborative sense and avoid that involves that all the aircrafts flying in this area installs one of these devices. So it's like a transponder or ADS-B. So all eVTOLs and drones flying will emit its position, so it can be read by other aircrafts nearby. And we also have non-collaborative technologies. So this non-collaborative will help us to detect birds, buildings, paragliders, all these kind of things that we can find during the flight and that are not involved in the collaborative environment. So for this, the existing technologies nowadays are mainly based in radar, LiDAR, and artificial intelligence using onboard video processing. But unfortunately, there are not yet 35 or sources of information that the autopilot can be used for enabling a fully autonomous flight. So in the certification programs that we are involved, we are following the detect and suggest philosophy. That it means that in case that the autopilot or the flight controller detects an obstacle, it will suggest an avoidance maneuver to the operator on board, but it is the decision of the operator to do this change in the route or not. Okay, so we can say that when it comes to detect and avoid, the level of autonomy that we can achieve right now with a certifiable basis is not to enable a fully autonomous flight. Yeah. Yeah. Communication is also an important factor to consider when on the eVTOL control, because as I mentioned previously, depending on the use and the kind of vehicle that we have, we may need it for different applications. Okay, so in some cases, maybe we don't need any kind of communications with other devices. In these systems, we can have an onboard operator, and we can rely on him all the responsibility to fly on a safe area and to make sure that the flight plan and everything that he has configured is safe and according to the law and to the air traffic management. But once that we reach to that point in which we have fleets of eVTOLs and we want them to move autonomously, and in some cases manned and in some cases unmanned, we will need to have a robust network of communication capable of sending data between them and also with the control centers on the ground, so everyone can be aware of the traffic surrounding the eVTOL flight. Yeah. And well, in this, unrelated to this, we come to the unmanned traffic management and the ATC integration. Okay, that at some point, all these vehicles should be interconnected with the authorities managing the flights of both UAVs and the eVTOLs. Okay. And in the way that all this technology is evolving, it looks like that it will happen through internet cloud, where all the systems involved in this environment will be interconnected. Okay, so we will have information coming from the eVTOL, showing their position, attitude, the route, and other parameters. We will have weather data services that will give information to the operators if they can fly in this area, or if they need to go to a landing spot, or if it is safe to fly. And we will also have the indications coming from the unmanned traffic and the manned traffic management, in which they will send information of the restricted flight areas, or they will give information on to authorize different kind of flights and to coordinate between the different vehicles flying. Okay, so it is important to make sure that the eVTOL control and the user interface, they are all interconnected with all this environment. So all the information needed for a safe flight is available to both to the authorities and to the people on board the eVTOL. Yes. And well, and this is what I wanted to show you regarding the eVTOL control and the main components and the architecture needed for this kind of flights. But well, now you want me to answer any questions or to go deeper in any aspect of the presentation, we can do it.
Great, thank you for that presentation. So we do have a few questions here. You mentioned the manual control is configurable based on the pilot experience. How is that practically implemented to maintain certification? And I think that's, yeah.
Yeah, well, the thing is that depending on the kind of aircraft that we are controlling, we can have a more or less degree of on the manual control. So, like for example, when it is like a fixed wing configuration, we can have a full manual control as if we were a light aircraft, because you can have all the controllers coming from the sticks go directly to the control surfaces, and the autopilot don't need to do any task there for the control. But when we control multi-rotor or a similar layout, the autopilot always need to do a part of the control, okay? Because it is not possible to control a multi-rotor in full manual. The pilot will not be able to do it. So what we have in the autopilot system is that the software of the autopilot is developed according to this DO-178 standard for proving the reliability. But then we have several configuration parameters that you can configure depending on the kind of vehicle and the kind of operation that you want to perform. Okay. So all these parameters, once they are configured, we go through a series of tests that complete the documentation for the certification according to the specific setup defined for the specific mission and aircraft.
Okay. And so the next one is about the failsafes on the motor controllers. So can you elaborate on how these are implemented? And is there a dual control path in the controller, or does it revert to a degraded control?
Yeah. Well, here we can follow these different strategies. Okay, but well, if we go to the decision that we have taken in the company to develop our motor controllers, these motor controllers, they have a dual input for the control. Okay, so you can have two different buses, two CAN buses, or you can mix one CAN bus with a serial port, or there are different configurations available. And with this, in case that one of the control signals coming from the autopilot fails because the cable is broken or whatever, the other signal will still remain active. So we can have the control of the motor controller. Anyway, in most of these eVTOL systems, we are having redundant architectures also for the motors and motor controllers. So usually if you lose one or two motors, you will still be able to fly.
Okay, and our next one is about batteries. So can you tell us if you're working with battery manufacturers, and if so, which ones, and what is the nature of your involvement and work?
Well, we are not really involved in the battery process. So we have customers working with different manufacturers and different brands. some of them are also trying with hydrogen fuel cells and other technologies, but it's not something that we are directly selecting or working in Embention.
Okay. You mentioned providing a system for Skydrive in Japan. Were you supporting their earlier drones, and what changes were necessary, if any, for the manned aircraft shown in your photo?
Well, yeah, we're working with them in different projects. Okay, some of them are for drones, and other are for this eVTOL that I saw you in the picture. And usually, when we integrate this kind of eVTOL systems, we first do some unmanned flights, okay, to do the first tuning of the control laws in the autopilot. And once it is flying as an autonomous vehicle unmanned, we put the pilot on board. We have other customers that they prefer to start flying manned from the early beginning, but usually we first work on the drone aircraft or the drone scale model, and then move to the manned version.
Okay. Can you tell us a bit more about your work with combat jamming? Sorry.
With what? Sorry.
Combat jamming.
Jamming. Yeah.
To combat jamming.
Oh, sorry about that. To combat jamming. Can you tell us a bit more about your work to combat jamming? Sorry.
I'm not sure what you mean with combat jamming. You mean the GPS, the jamming of the GPS signal?
Yeah. So your work to, I guess, stop others from jamming your communications.
Oh, yeah. Yeah, sure. From the autopilot point of view, we can define different fail-safes in the system. Okay, so these fail-safes is basically a series of events that triggers an action in the autopilot. Okay, so what we usually do when defining the autopilot configuration is to try to detect all these possible errors or jammings that we can have, and then set a mitigation action. So, for example, when it comes to the communications, in some cases the communications are not critical, and sometimes they are. So if we are being jammed in the communications, we try to we can define different strategies. So sometimes we try to fly higher to get out of the jamming area, okay, and some other times we just go to landing, and in some other cases we try to put different kind of redundancies. Like, for example, we can put radios working simultaneously in different frequencies, or we can have a line of sight radio plus SATCOM. So, because usually when you get jams in terms of communication, you get jammed for a range of frequencies. So, if you are able to install in the eVTOL different communication systems that are not close in the frequency band, you can avoid the jamming. And when it comes to the GPS jamming, we have algorithms that, based on the IMUs and the other sensors on board, can still maintain a stable flight. Okay. And we are now interfacing with some companies doing like video processing and other kind of technologies to provide also a redundant source of positioning besides the GNSS position.
Okay. Do you utilize ultra lightweight carbon composite materials for your device and electronic enclosures?
Well, nowadays all our enclosures are built with aluminum. Okay, and it is because we are passing some tests on the DO 160 and the middle standard 810 that put really high requirements on the robustness of the system and the resistance to electromagnetic interferences and other environmental factors. And we achieve really good results with the aluminum. So maybe moving to carbon fiber is something that we have considered it sometimes, but for now we are using aluminum.
Okay. And just to follow up on the jamming question, I think you talked a little bit about combating the jamming once it happens, but how are you working to prevent that jamming from happening, or are you?
Well, preventing the jamming is not so easy. We have some customers that they are installing some kind of waves reflectors to protect their GPS antennas, or that they are having different antennas to the system. So with this, we can detect if we get different signals on different antennas, we can do an early detection of the jamming.
And what do you see as the timeline for the first UAVs to be commercially implemented since the FAA approved, I'm sorry, Terrafuga this week?
Yeah. Well, I think it's something that will happen soon. I think we have some customers that they have already certified drones for different kind of operations, and we have some customers that they are already working on the certification of the eVTOL systems.
Mm-hmm.
So this eVTOL certification, we think that we should be the first certificates within 1 or 2 years.
Okay, and then another question: do you have offices in the U.S. or as well as Spain?
Yeah. Well, we are based in Spain, but our customers are worldwide. We are selling now in more than 70 countries, so have several projects going on everywhere.
And so because of your experience in the UAV area and kind of taking that and putting it in the drone area, and how they're both kind of working on the certification paths, you had mentioned in your presentation that one of the differences between drone autopilot and eVTOL autopilots is when you have someone on board, you know, you got to be a little more careful with the movements, and you can't move as quickly. Can you talk about some of the other differences and how you're kind of transitioning from your experience in the drone area and how you're using that to get to the eVTOL autopilots?
Well, also one of the main aspects here is the need of a higher grade of readability in the systems. Okay. I mentioned that we work with the DO 178 and the DO 254 regulations. That these regulations involve, well, they have like different levels of compliance that you can achieve. Okay. So now we are compliant up to DAL B. Okay, that is like the second step in the regulation, and we are already working to get the DAL A, that is the highest standard, that is the one that is now required for civil and manned aviation. Okay, so maybe this is one of the main difference that what we still need to do to complete some of the testing that we are doing on the software to move from DAL B to DAL A. That well, we expect it to happen within this year. Okay. So maybe all these aspects related to the reliability is the more challenging, because you have to well, now you have someone on board, so critical in the system can result in someone dead. So this is why we also have improved our hardware to make a more robust redundancy management system. So, and we have worked a lot on the voting algorithms to manage this redundancy. Okay, so all the main work we have done to move from the UAV autopilot to the eVTOL autopilot is based on the improving the safety and the reliability.
Okay, and you mentioned that whenever you're testing a system, you start out with unmanned, correct? And then if you wanted to test a configuration, you move to from unmanned to manned, correct?
Yeah, in most cases we do it. It is also because most of our customers, they not only because of the autopilot, but because they want to test other systems, they have scale models of their aircraft. So it is quite common to do a first integration on a drone vehicle with a similar layout to the big one, and then move to the big one.
Okay, and let's see, we have another question coming in. Are you working on what might be considered unexpected forms of interference with the aircraft? For example, Amazon sends a drone to deliver a package and someone in the neighborhood or even the customer themselves decides to just swat or shoot the drone down. How do you develop for this situation?
Yeah, well, I think all these will be it is, I think this kind of development is more involved with the people itself, that once they need to get used to see drones, and they need to get used to see that they are there and they cannot shoot it. So, yeah. But from the autopilot perspective, well, the only thing that we can do is to make these systems fault tolerant. So in case that one of the systems fails because it has been damaged by a third party, we can still fly and we can detect this failure and command a go home, or maybe another action in case it is so critical for the flight. But from our side, the major development is all this failure detection and failure tolerance.
And you know, that brings up something that a lot of people talk about with eVTOLs and drones, just, you know, getting people who aren't in the industry to trust them. How are you working to, you know, get people to trust your autopilot system? If they were to, you know, no pilot experience, they're getting in an unmanned eVTOL, how do you get them to say, yes, our autopilot system is, you know, you're not going to fall from the sky?
Yeah, well, this is why we are following these DO standards, okay? Because even when we were working with only with drones, we were already using it, and because of that, one of our customers was the first company in Europe to get a type certificate for AirPass. So, yeah, the main source of reliability that we can provide is that we follow the same standards that are used for manned aviation. So if the people trust an autopilot in an airliner, we are following the same standards that they do. So.
Great. Well, I don't think I have any more questions, and I don't see any more questions in the queue. I do want to give you an opportunity to add anything else that you didn't already add.
Yeah, well, maybe related to your previous question, we are also working in some of the programs that we are working with eVTOL. What we are doing also is that in the autopilot system, you can define like different levels of complexity for the manual flight. Okay, so if you have a pilot that is the first time that he is flying with this vehicle, maybe he can only go up and down, and once he do it 10 times, he can move to the next step, that is to move really slowly. Okay, so we are increasing the grade of action that can be controlled by the manual pilot as they get more experience and more confidence in the whole system.
Great. Well, thank you very much for your presentation and for answering all our questions. Jim, do you want to pop on at the end, or?
Yep. So let me first thank Javier. Great presentation. Some good information, and I think the folks that were on got to know a little bit more about Embention and what your capabilities are, and that should lend itself to some better exposure in the space. And Kelsey, thank you for taking on this role of moderator today and doing a fabulous job keeping things moving along and getting some great teasing out some great information. So I want to thank you both, and thank our attendees today for listening in. This recording will be posted up on the VFS website, YouTube site, and as well as Javier has given us permission to post the slides as well. So if you missed something along the way, you can go back and check it out again. So this is an ongoing series, and we'll have some more interviews coming up over the next few months. I just want to point out that our next main event is the eVTOL infrastructure workshop coming up from March 2nd to the 4th. That will be a virtual event, and it's going to be focused mostly on eVTOL policy for infrastructure. So we have 3 full days, well, three-quarter days of intriguing policy presentations to try to move the infrastructure piece along rapidly, or more rapidly. And then, of course, our main event is the VFS Annual Forum, which will also be virtual, and that will be held from May 10th to the 14th. And we look forward to having you all participate. So with that, I will wrap it up and say goodbye until next time. So thanks again, Kelsey and Javier, and we wish everyone a great day. So
thank you all.
All right. Ending now.